Correlation and regression. Topics for discussion include: correlation shows the relationship between two variables, often visualized with scatter plots. The coefficient of correlation measures the strength of this relationship, while the coefficient of determination indicates how much variance is explained. Linear regression predicts outcomes based on this relationship. Correlation refers to the degree of association between two or more variables, measuring how closely they are related. It is commonly used as a statistical tool to analyze the relationship between variables and is quantified by a correlation coefficient, which ranges from -1 to 1. A correlational study can yield three possible outcomes: positive correlation, negative correlation, or no correlation. A positive correlation occurs when two variables increase or decrease together, while a negative correlation occurs when one variable increases as the other decreases. If there is no consistent relationship between the variables, no correlation is observed. A positive correlation occurs when both variables increase or decrease together, such as height and weight. In a negative correlation, one variable increases while the other decreases, like the speed of a car and travel time. No correlation means there is no evident relationship between the variables, for example, shoe size and intelligence. Simple correlation refers to the relationship between two variables, where a positive correlation occurs when both variables increase together, and a negative correlation occurs when one variable increases while the other decreases. Partial multiple correlation involves three or more variables, where partial correlation focuses on the relationship between two variables while holding others constant, and multiple correlation examines all variables simultaneously. In linear correlation, changes in one variable maintain a constant ratio to changes in the other, whereas non-linear correlation reflects a relationship where the ratio of change between variables varies. There are two main methods for studying correlation: the graphical method, which uses scatter diagrams to visually represent the relationship between variables, and the algebraic method, which involves calculating Karl Pearson's coefficient of correlation to quantify the strength and direction of the linear relationship between variables. A scatter diagram is a graphical tool used to identify relationships between variables by plotting data points on a Cartesian plane, with each dot representing an x and y value. A greater dispersion of points on the graph suggests a weaker relationship between the variables. Correlation between variables can vary in strength and direction. A perfect positive correlation occurs when the variables move together in the same direction, while a perfect negative correlation happens when they move in opposite directions. A high degree of positive correlation means the variables are strongly related positively, whereas a high degree of negative correlation indicates a strong inverse relationship. Low degrees of positive or negative correlation show weaker relationships in their respective directions. No correlation signifies no discernible relationship between the variables. Scatter plots offer several advantages. They provide clear visualization of relationships between two variables, help identify outliers, and are simple to create and interpret. They are versatile, accommodating both small and large datasets and various data types, and can be used for multivariable analysis by incorporating colors or shapes. Scatter plots have several disadvantages. They focus solely on visualizing relationships between two variables, which limits their scope. In large datasets, overlapping points can obscure patterns, making analysis challenging. The interpretation of scatter plots can be subjective, particularly regarding the strength of relationships. Additionally, scatter plots do not provide direct numerical measures of correlation. As a teacher, you are investigating how the number of hours students study for an exam impacts their exam scores, hypothesizing that more study time may result in higher scores. To explore this, you collected data from 20 students, recording their study hours and corresponding exam scores. To create the graph, first prepare the axes by labeling the x-axis as study hours, and the y-axis as exam score. Next, plot points for each student where their study hours intersect with their exam score. Complete the graph by repeating this process for all 20 students, marking each data point accordingly. The coefficient of correlation, developed by Karl Pearson, quantifies the degree of linear association between two interval-scaled variables, with a range from -1 to 1. A coefficient of r equals 1 indicates a perfect positive linear relationship, where both variables increase together, r equals -1 signifies a perfect negative linear relationship, where one variable increases as the other decreases, and r equals 0 means there is no linear relationship between the variables. To calculate the Pearson correlation coefficient, r, first find the mean of both variables. Then, subtract the mean from each data point for its respective variable. Multiply these differences for each data point and sum the results. Finally, divide the sum by the product of the square roots of the sums of the squared differences for both variables. Using the same scenario as before, calculate the coefficient of correlation based on the provided data. Then, analyze and comment on the observed correlation, noting how strongly the variables are related and the direction of their relationship. To start, calculate the means, averages, for both study hours, x, and exam scores, y. For study hours, the mean is 3.1, and for exam scores, the mean is 70. To assess the relationship between data points, first calculate the differences between each data point x and its mean. The coefficient of correlation, r, is then used to quantify the strength of this relationship. In this case, r equals 0.994 indicates a high degree of linear positive correlation. The coefficient of determination ranges from 0 to 1 and measures how well a statistical model predicts an outcome by quantifying the proportion of variance in the dependent variable explained by the independent variable. It is derived by squaring the Pearson coefficient of correlation. For example, with an r value of 0.994, the coefficient of determination is 0.988, meaning 98.8% of the variation in the output, y, is explained by the input, x, while 1.2% is attributed to other factors. Regression is a statistical method used to model and analyze the relationship between a dependent variable and one or more independent variables. It seeks to estimate the dependent variable based on the values of the independent variables, facilitating predictions and providing insights into the nature of these relationships. Regression involves predicting or estimating the value of one variable based on the known value of another. It uses an equation derived from bivariate data to make these predictions, and the regression curve represents both the equation and its geometric depiction for forecasting outcomes. In regression analysis, the dependent variable, y, is the one being predicted or influenced, while the independent variable, x, is used for prediction or estimation, also known as the predictor or explanatory variable. The regression line is a line fitted to data points to estimate the relationship between these variables, and the regression equation is determined using the least squares method to identify the best fitting line. The simple linear regression model is a statistical technique used to examine the relationship between two variables by fitting a linear equation to the data. It helps in predicting the value of one variable based on the value of another by establishing a straight line relationship between them. To find the linear regression equation for the given data sets, start by determining the equation of the line that best fits the data points. This involves calculating the slope and intercept to form the equation y equals bx plus a. Next, plot the data points on a graph to visualize the relationship. Finally, use the regression equation to predict the value of y when x equals 9. To find the linear regression equation for the given data sets, use the coefficients a and b where b equals 0.95 and a equals 1.5. The linear regression equation is then determined as y equals 1.5 plus 0.95x. To determine the linear regression equation for the given data, use the formula y equals 1.5 plus 0.95x. Plot the points by graphing the data on a coordinate system. For x equals 9, substitute into the equation to find y. 1.5 plus 0.95 times 9 equals 10.05. Thank you for watching.